Hello friends, so welcome to the lecture 5 of the linear programming topic. So in this video we will be starting the exercise 7.2. So in this last video we have seen how we can add the two more non-negativity constraints in the given system of inequations. Okay, so if you have not seen that video, please go through that and come back to this video. Now let's get started the exercise 7.2. So let's have the first question. For all these set of questions, we have to find out the feasible solution set. Okay, so it says that, so let me zoom it so that it's easy for all of us. So it says that find the feasible solution of the following inequations graphically. Okay, graphically means coordinate axis plane, that's for sure. So first line, that is first inequation, second inequation, third and fourth. So these two are called as a non-negativity constants. Okay, so first step is what? Get these equations as it is. So it is 3x plus 2y less than or equals to 18, 2x plus y less than or equals to 10, x is greater than or equals to 0, y is greater than or equals to 0. First step is what? Get the equation, convert the inequality into equation. So it is equals to 18, 2x plus y equals to 10. No need to change here in these two as they do not create any problem for us. So next step is what? Get the double intercept form. So it is 18 by 3 is 6 plus y divided by 18 by 2 is 9. It is equals to 1. X by 5 plus y by 10 equals to 1. As it is. Okay, then we have to plot these lines on the coordinate axis. So let me draw the y-axis and x-axis here. So this is what we get, the y-axis and x-axis. Perfect. Okay, x-axis and y-axis. So let's have the 6 on the x-axis. So here we have somewhere 6 and at 9 on the y-axis. Suppose this is 9 we have on the y-axis. Let's join these two lines. Sorry, these 2 points, not lines, and rewrite the equation, which is nothing but 3x plus 2y, this is equals to 18. This is what the line equation is. Get the second point, 5 and 10. So 5 you will have somewhere here 5 and 10 here you will have somewhere here 10. Okay, join these 2 points. So this will be somewhat like this. Okay, so let's join these 2 points. So this is how the line is. Write the equation, which is nothing but 2x plus y, it is equals to 10. And the second two inequations are simple. They are positive x-axis and a positive y-axis. Okay, let's now draw the common region. Okay, so without common region also you can now directly specify for these two. Okay, but for these two inequalities we have to check whether this feasible solution set is including 0 or not in that. So for that what we have to do is substitute 0 0 in the given inequation, which is nothing but this 3x plus 2y. So it is 3 into 0 plus 2 into 0, which is less than or equals to 18. So 0 is less than or equals to 18. Absolutely fine, no problem. So first line includes the 0 in its feasible solution. What about the second line? So it is 2 into 0 plus 0 less than or equals to 10. So 0 less than or equals to 10. Absolutely fine, no problem. Means what? Both the lines include the origin in their feasible solution. Okay, so what is the common region for all of these? So if I combine each and every feasible solution, so what I will get is positive x-axis, matlab this side you will have upside. Okay, so this is what we have, the positive x-axis. Okay, and what about our positive y-axis? So this will be what we have, the positive y-axis. So this is what we have, the positive y-axis, and both the lines include the origin in their feasible solution. So what will be the common region to all of these is nothing but this part. Okay, do not include this part as this is not the feasible region for the first line. See, this point and these two regions are not a part of feasible solution for the first line. That's why you cannot simply include this in the feasible region. Okay, so after combining, what region I am getting is nothing but this much region I am getting. So this much region is very important. Okay, so this is what we get, the region which is the feasible region for these given system of inequation. Great. Okay, now let's see the next question. So it's very simple topic. So second inequations are nothing but 2x plus 3y. So let's zoom it. Now I will directly draw the inequations and will directly plot the feasible region. Okay, so it is 2x plus 3y equal to 6, x plus y equals to 2, x is greater than or equals to 0, y is greater than or equals to 0. So convert into double intercepted form. So it's a y by 2, it equals to 1, x by 2 plus y by 2 equals to 1. So what about the point 0, 0? 0, 0 is included or not? So it is 0 plus 0 is less than or equals to 6. Yes, this is absolutely correct. What about the second? So 0 plus 0 is greater than or equals to 2. So 0 is greater than or equals to 2. Is it correct? No, it is not. Okay, so origin 0 comma 0 not included in the solution set, but here as it is correct, the 0, 0 is included in the solution set. Okay, so let's draw the x-axis and y-axis. So let's have here somewhere we have the x-axis and this is y-axis and x-axis. Let's plot the points. So it is 3 comma 2, so 3 on the x-axis, 2 on the y-axis. So let's join these 2 points. This is how you get the line. Write on the equation of line, which is nothing but 2x plus 3y equal to 6. Take the second, so it is 2 comma 2. So ये था 3, ये था 2, and we have the 2 comma 2. So this is 2 and this is 2. Draw the line now. So you will have the line somewhat like this. So write down the equation again. So this is nothing but x plus y, it is equals to 2. X is positive, y is positive. So what do you think? What is the feasible region for this? So feasible region for this, so let me have, the feasible region for this is nothing but, for first line 0 is included. So this was our first line and 0 is included, matlab kya? This is the feasible region. And for the second line 0 is not included, means for this our feasible region is like this. So let's have that feasible region. Okay, greater. And for these two both we have the positive x-axis and y-axis. So what do you think? What is the common region to this? So this is nothing but the common region for the given system of inequation. Okay, so I hope it is clear. Is it okay, everyone? Great, that's great. Now let's see the next question now. The question number 3. It says that 3x plus 4y is greater than or equals to 12. Let's zoom it again. Perfect. Okay, so let's take the equation as it is. So 3x plus 4y greater than or equals to 12, 4x plus 7y less than or equals to 28, y is greater than or equals to 1, and x is greater than or equals to 0. Somewhat different constraint you have in this question. Okay, no worries, the concept is very clear, so we can solve for any given constraints. Write down the equation format. So it's a 3x plus 4y equals to 12, 4x plus 7y equals to 28, y is equals to 1, and x is greater than or equals to 0. Okay, let's have the double intercepted form. So x divided by 4 plus y by 3 equals to 12, x by 7 plus y by 4 equals to 28, and y is equals to 1 and x is greater than or equals to 0. Means what? X is positive and here y is 1. Okay, let's have the origin. Let's have the origin verification whether the given solution set for the first line and the second line includes the origin or not. So substitute given inequalities 0 0. So 3 into 0 plus 4 into 0, which is greater than or equals to 12. So 0 greater than or equals to 12. Is it correct? No, of course not. Means what we can say is 0 0 not included in the solution set of the first line. What about the second? So it is 4 into 0 plus 7 into 0 less than or equals to 28. So 0 less than or equals to 28, absolutely fine, no problem. So 0 0 is included in the solution set. Okay, great. See, y is greater than or equals to 1 means what? It's a right side of the y is equals to 1 line. Okay, sorry, it's a right side nahi aayega, it's a above the y equals to 1 line. Okay, let's draw these lines here. So y is equals to 1 and x is greater than or equals to 0. Let's have the axis here. So y axis, x axis, y and x. Let's have the coordinates, intercepts, that is 4 and 3. Suppose this is 4 and this is, we have 3. First line, 4 and 3 first line. So somewhere here you will get 4 and 3 line. Write down the equation as it is. So it is nothing but 3x plus 4y is equals to 12. 3x plus 4y equals to 12. What about second line? So it is 7 and 4. So 7 here and 4 somewhere here you will take. Okay, let's join these 2 points now. 7 and 4. Okay, 7 and 4. Let's write down the equation here. So this is nothing but 4x plus 7y equals to 28. Y is equals to 1. Suppose I take this point as 1. Okay, this point as 1. Y equals to 1 will be somewhat like this. This is what we have, the y equals to 1 line. Okay, write down the y equals to 1. And of course x is positive means what? Right side of the y axis. Okay, now let's have the feasible region for all the lines. For the first line you do not include the 0 here. So this is our first line and you do not include the 0 means what? It is above this line is my solution set. Yes or no? Perfect. For the second line 0 is included. So what is the solution set? 0 is included मतलब क्या है? ये region रहेगा. 0 is included मतलब below the line. But you have x is positive means what? All the points which are on the positive x-axis, and y is greater than 1. For that, what is the solution set? Y is greater than 1. For that, what is the solution set? So let me have the purple. Y is greater than or equals to 1 मतलब क्या है? This will be the solution set now. Now find out the common region here. In this case, the common region will be in between these two lines. Okay, I find this is what the common region is. Perfect. It is absolutely greater than 1 for y, and it is absolutely positive for x, absolutely below the second line, and absolutely above the first line. So this is what you get, the feasible solution set, common feasible solution set for the given system of non-equations. Yes, of course. So in this way you can add any constants other than greater than or equals to 0. Okay, now let's see the question number 4. So it says, perfect. Okay, let's zoom it now. Write down the equations as it is. So it is nothing but so let's have Okay, yes. So it's a 4x, it's x plus 4y less than or equals to 24, 3x plus y less than or equals to 21, x plus y less than or equals to 9, x is greater than or equals to 0, y is greater than or equals to 0. That's great. See here, if you observe, we have 5 inequalities in this, from out of which 2 are non-negative constants. Okay, by kitna bhi inequalities de do, we have the concept with us. Okay, we can solve for any number of inequalities. First step is what? Get the double interest. Oops, first get the equation of line. X plus 4y equals to 24, 3x plus y equals to 21, x plus y equals to 9, x positive, y is also positive. X by 24 plus y by 6 equals to 24, x by 7 plus y by 21 equals to 1, x by 9 plus y by 9 equals to 1, x is positive and y is also positive. Okay, let's check for the origin whether 0 0 is satisfied. So 0 plus 4 into 0 less than or equals to 24, 0 less than or equals to 24, no problem. So 0 0 is included. Okay, what about next? 3 into 0 plus 0 less than or equals to 21, 0 less than or equals to 21, no problem, the origin is included here also. What about third? 0 plus 0 less than or equals to 9, 0 less than or equals to 9, no problem, again the origin is included in the feasible solution set for the third line. Okay, so having this, let's plot this figure. Get the Cartesian axis, x-axis and y-axis. So huge range of x and y values is required for this question. See here, 24 on x, 21 on y. Okay, so let's have 24 on x first. This is what we have, 24 on x, and the 6 on y. So let's have somewhere here 6 on y. Let's join the points now. Let's join these 2 points. Oops, sorry. Let's join these 2 points. So you will have the points like this. Perfect. Okay, let's name this line, which is nothing but x plus 4y equals to 24. So it is x plus 4y equals to 24. Let's have the second point now, which is 7 and 21. 7, so here is somewhere I will have 7, and 7 21. So here I will have 21. Okay, now let's join these 2 points. So this will be the case now. Okay, the third line. Okay, first write down this equation, which is nothing but 21x plus 7y equals to 21. Okay, so I hope it is clear. So it's a 3x plus y equals to 21. So it's a 3x plus 7y, 3x plus y. Okay, let me write. It's a 3x plus y equals to 27. Oh, 21. Sorry, it's 21. Okay, 3x plus y equals to 21. Now let's have the next line, which is 9 points. So let's have the 9 somewhere here and 9 somewhere here. 9 point will be somewhere here. So let's join these 2 points. Great. Okay, cool. So let's name this. So x plus y equals to 9. This is what I get the third line. Now let's have the feasible solution set for all of these 3 lines. Of course, the x and y both are positive from these constraints. ओके, मार्क दिस सॉल्यूशन सेट. सबके लिए origin is included. Okay, means what will be the common region if I have the positive x-axis and y-axis? So this will be the common region. Okay, so no need to draw the solution set for all. Okay, so this is what you get, the solution set, the common solution set, because each and every line includes the origin in their respective feasible solution. So this is what we get, the common feasible solution. Okay, I hope you are getting this. Now let's see the next question. So the next question is, okay, so it says that 0 less than or equals to x less than or equals to 3. Good question. So let me have the space. Let's zoom it. Oops, sorry. Okay, so write down the inequations first. So they have given the inequations in some different format. Now they have given the constraints first and then they have given the inequations. So let me write in the standard form. So it's x plus y less than or equals to 5, 2x plus y greater than or equals to 4. Constants are what? 0 less than or equals to x less than or equals to 3, 0 less than or equals to y less than or equals to 3. Okay, see, once you understand these constraints, now half of the solution is done. Visualize this region. X is in between 0 and 3 and y is also in between 0 and 3, means what value of x you can expect here? You can expect as it is 1, 2, 1.2, 1.5, okay, 2.9, but can I have 3.1 or -1? No. So those type of visualization you should have by this time. Okay, now let's continue our procedure. Convert into these equations. Equals to 5, 2x plus y equals to 4, x by 5 plus y by 5 equals to 1, x by 2 plus y by 4 equals to 1. Let's check for the origin. So 0 plus 0 less than or equals to 5. So 0 is less than or equals to 5, satisfied. So origin is included. What about second? So 2 into 0 plus 0 greater than or equals to 4, 0 greater than or equals to 4. Of course not, so it is not included. Okay, included. The origin is not included for the second line. Okay, now let's draw the figure. So we have the x-axis and you have the y-axis. Okay, have the first point 5, 5. So suppose this is 5 and this is 5, 5, 5. Let's join these 2 points. This is how the first line looks. So equation is x plus y is equal to 5. What about the second line? It is 2 and 4. So 2 on the first x-axis, 4 on the y-axis. Let's join again these 2 points. So the line looks somewhat like this and the equation will be 2x plus y is equal to 4. Okay, 0 less than or equals to x less than or equals to 3. So plot x is equals to 3 line. So ये तो हो गया अपना 2. So this is what we have the 2 and this is what we have the 4. Draw the x is equals to 3 line. Draw the x equals to 3 line. So that will be parallel to my y-axis. This is nothing but x equals to 3. And draw y equals to 3 line. So here somewhere I will get the y equals to 3 and the line will be like this. Oops, sorry. The line will be like this. This is what we get, y is equals to 3. Okay, so now check for the feasible solution set. Do you still require to draw the feasible solution set for individual lines? No, we will only draw the solution set for this lines inequalities. So for the first line, origin is included, so this is my first line. Origin is included means what? It is the below the line. Okay, and origin is not included for the second line, means it is above the line. Okay, ye below ho gaya, this is what the below the line, and this is the above the line. Okay, and for the first constraint, which is x is lying between 0 and 3, means what? This much is the region for the x. So this much is the region for the x. So if I combine, I will get this region. Okay, but if I still combine for y, the y is lying in between these regions, so 0 and 3, means what? In charo ka if I do combination, what sort of feasible solution I am getting? So this is what I get. Yes, this is the solution set for the given system of inequation. I hope you are getting this. Y can take any value from 0 to 3 and x can take any value from 0 to 3. So that's why we have bounded these regions. Good. Now let's see the next question. It's a question number 6, and I hope this is the last question, which is direct question, we can say. Yes, it's the last one. So let's zoom it. Okay, oops. Okay, so it is nothing but x minus 2y less than or equals to 2, x plus y greater than or equals to 3, minus 2x plus y less than or equals to 4, x is positive and y is also positive. Okay, don't worry about these negative signs. These are just very simple concepts. Okay, first step is what? Get the standard form. X minus 2y equations. 2 x plus y equal to 3 minus 2x plus y equal to 4, x 0 y greater than or equals to 0. Get the double intercept form. X by 2 plus y by minus 1 equals to 1, x by 3 plus y by 3 equals to 1, x by minus 2 plus y by 4 equals to 1, x is positive and y is also positive. If you have not understood this, how I have converted, please watch my first video, you will get understand. Okay, just I have converted the standard equation into the double intercept form. Okay, let's check for the origin whether it is included or not. Substitute 0 0 in the first inequation. So 0 minus 2 into 0 less than or equals to 2. So 0 less than or equals to 2 satisfied. So 0 0 is included. No problem, the 0 0 is included in the solution set. What about second? So 0 plus 0 greater than or equals to 3. 0 greater than or equals to 3, not satisfied. So we say it's a not included in the solution set. Okay, now let's draw the lines as given by the double intercept form. So x-axis and y-axis we get here. Okay, get the points. So first, for the first point we have 2 and minus 1. So it's a 2 and it's a minus 1. Join these 2 points. Write down the equation, which is nothing but x minus 2y equals to 2. It is x minus 2y equals to 2. Get the second line, which is nothing but 3 comma 3. So it is 3 on the x-axis, 3 on the y-axis, and the equation is x plus y. So ये था अपना 2 and minus 1. So this point was 2 and this point was minus 1. Now you have 3 and 3. So this is 3 and let's say this is 3. Join these 2 points. Okay. Okay. Write down the equation, which is nothing but x plus y equals to 3. ये 3 हो गया, ये 3 हो गया. And both the x and y are the positive values. X and y both are positive values. So get the feasible solution. For the first line, 0 0 is included. So this was my first line. Okay, 0 0 is included means, what do you think, which is the feasible solution? Of course, this is the feasible solution for the first line. For the second line, 0 is not included मतलब क्या है? This is the feasible solution for the second line. Of course, now both are positive, x be positive and y be positive, means what do you think? What will be the feasible solution common to all? So this is what I get, the common to all feasible. Sorry, ये part नहीं आएगा. Okay, so this much will be the common. Okay, इसके ऊपर and इसके इधर ऊपर and x के इधर ऊपर. So this is how I get the common region, and it will go like this, unbounded region. Okay, that's cool. I hope you have understood this concept again. Oops, I forgot one more point here we had, which is actually okay, no problem, we can include that. So let me first erase the solution set, common solution set, which we have marked just now, because there is one more line which we forgot here. No worries, we can include anytime. So this is nothing but x is at -2, x is at -2, it's -1 -2, it's -2, and y is at 4. So ये 3 हो गया, तो y is at 4. Okay, let's join these 2 points now. Okay, cool. Can we have the origin for this point in the solution set? So it is -2 into 0 plus 0 less than or equals to 4. So 0 less than or equals to 4. Is it true? Yes. Means what? Origin is included in this solution. So this is what you get, the feasible solution for this line. Okay, now tell me what is the common region for all of these. So of course, so this is what the common region for all. Okay, so I hope it is clear everyone. You can add any number of inequalities in this. Great. Okay, so let's see the next question now. So the next question is, yes, now we have the descriptive type of questions, which are good actually. Okay, yes, so let me paste here. Let's zoom it. Okay, let's first try to get the inequalities with the help of this passage. A company produces two types of articles. Okay, so we will write down the articles here. Articles A and article B we have, which require silver and gold, so they require silver and gold. Good. A unit A requires 3 gram of silver. Unit A require 3 gram of silver. Okay, so let's write down here x and let's write down here y. 3 gram of silver A requires, and 1 gram of gold. Okay, A requires 3 silver and 1 gold, whereas the unit B requires 2 gram of silver, 2 gram of silver and 2 gram of gold. Okay, no problem. The company has 6 gram of silver. Okay, so what is availability you have? Availability कितना है बॉस? कंपनी के पास टोटल 6 ग्राम ही अवेलेबल है सिल्वर एंड 4 ग्राम गोल्ड अवेलेबल है. Okay, so construct the inequations and find the feasible solution graphically. Okay, now tell me what will be the solution set, inequations here. You can use any number of grams silver and any number of grams for gold, but you cannot exceed your utilization for silver and gold as a 6 gram and a 4 grams respectively. Okay, so what will be the equation? So for silver, which is nothing but you will have 3x plus 2y. Is it okay? What is x and y? X is nothing but the number of grams you are using for the article A and B. So for the first you are getting 3x plus 2y, which is less than or equals to 6. Yes or no? Because the maximum availability is how much? It's 6. and for the gold, how much we have? I have x plus 2y which is less than or equals to 4. Okay, and where x and y are what? X and y are the number of grams of silver and gold, sorry, number of grams utilized in the article A and B, number of grams utilized in A and B, articles A and B, number of grams utilized in the article A and B. See here, A and B requires the silver and gold. Okay, A कितना मिल रहा है A को? It is taking the 3 grams and article B is taking 1 gram of gold. Okay, but actually I don't know how the article A is going to utilize this. So that's why I have is a 3x plus 2y is less than or equals to 6, and the second constraint is x plus 2y is less than or equals to 4. And definitely the next two constraints will be what? As the x and y are the quantity, they cannot be negative, so I have to take them as a positive only. So x is greater than or equals to 0, y is also positive. Good. Okay, so writing these 4 constraints will give you full marks for this question. Okay, if the question is this much only, construct the equations. If you do not write these two constraints, you will definitely losing 2 marks for this. Half of the questions, half of the marks you will be losing for these two constraints. Very important constraints these are. Now let's form the graphical solution and let's find out the common feasible region for all of these given system of inequations. Okay, so first one is 3x plus 2y equals to 6, x plus 2y equals to 4, x is positive and y is also positive. X by 2 plus y by 3 equals to 1, x by 4 plus y by 2 equals to 1, x positive, y is also positive. Okay, check for the origin. So it is 3 into 0 is 0 plus 2 into 0 is 0 less than or equals to 6. Yes, so we can say it's included. What about second is, it is 0 plus 0 less than or equals to 4, accepted. So again the 0 is included in this region. Okay, now let's have the x-axis and y-axis. This is what we have, x-axis, y-axis. Let's plot the lines. So it is 2 3 4 2 2 3, we have 2 3 and we have 4 and 2 2 3. Let's join these two lines points, 2 3 and 4 2. Okay, and let's name these equations. The first equation is nothing but 3x plus 2y is equals to 6, 3x plus 2y equals to 6, and the second equation is nothing but x plus 2y equals to 4, x plus 2y equals to 4. Okay, and of course x and y both are positive. Now tell me, for both of the equations we have the 0 is included in the feasible solution. मतलब क्या आएगा, इसका नीचे का पार्ट आएगा and इसका भी नीचे का पार्ट आएगा. Okay, but both the x and y are positive. So what is the common feasible solution here is, so this part is nothing but the common feasible solution you will get for this question. Okay, I hope you are getting the concepts. Okay, so you will be getting these concepts if you have followed all the videos. Okay, now I am writing the solution sets directly. I have writing these included, not included steps directly I am denoting the common feasible solution. Okay, please, if you are not following, understanding this, please go and watch my previous videos. Okay, great. So this is what our common feasible solution is for the given question. Now let's see the last question of this exercise, so which is nothing but a furniture dealer. So क्या कर रहा है furniture dealer? So let's see what he is doing. Okay, great. A furniture dealer deals in tables and chairs. He has 1,50,000 to invest and a space to store at most 60 pieces. Okay, a table costs him 1500 and a chair 750. Construct the inequations and find the feasible solution. Now tell me vertical items and horizontal items, which items you will take as vertical and which as a horizontal. मतलब क्या है कि what I will write this side and what I will write this side. See, always remember, you first, to remove this ambiguity, first write down the availability. Okay, so let's write down the availability. How much availability you have is 150,000 for the what? Investment. Okay, so investment is what you get the horizontal, and you get the store for the 60 pieces. So you get the store, which is the number of pieces you get here, number of pieces you get, which is at most 60 should be there, and 1,50,000 should be the maximum amount the manufacturer, there is a furniture dealer, is investing. Okay, so the remaining two will come here. So you will have tables and you will have chairs. So this is how you get the complete picture of the inequalities. Now our task is to just fill these blanks. A table cost him, let's write down the x and y. So x and y, so what is x and what is y? X is number of tables and y is number of chairs. Okay, so fill the table. So a table cost him 1500. So here you will have table x का investment cost कितना है 1500 and chair cost him 750, no doubt. What about the next constraint you have is, here you have the x number of tables and y number of chairs. Okay, so let's have, of course, now see the second constraint is what is this space to store at most 60 pieces. Okay, so what you have considered x and y are the number of chairs and table, number of tables and chairs. So that's why I have written this x and y as it is. So what will be our first constraint? What will be our first inequality? So it is 1500x plus 750y. It should be less than or equals to 1,50,000, because this is what he is investing for manufacturing. Okay, and the next inequality is 6 plus y, sorry, x plus y is again less than or equals to 60. The next constraint will be what? Positive x and positive y, because both are the quantities of tables and chairs, so they cannot be negative. So these are what? Constraint 1, constraint 2, constraint 3 and constraint 4. If you write all these fours, you will get full marks. If you leave these two, you will lose half of the marks. Okay, now let's write the inequations and let's find out the common feasible solution. Okay, 750y, which is equals to 1,50,000. Second is x plus y is equals to 60 and x is greater than or equals to 0 and y is also positive. Okay, let's write here. So in the double intersect form you will get x divided by, so ये those zeros चले गए, so I will be remaining with the 100 plus y divided by, so ये आ गया मेरा 0 0 cancel हो गया, so I will be having, so 200. I hope it's correct. Yes, so it is equals to 1. What is next is x by 60 plus y by 60. It is equals to 1. X is positive and y is also positive. Okay, now let's check for the origin. So origin is what? It is 0 plus 0 is, the constraint is what? It is less than or equals to 1,50,000. Yes, it is of course true. 0 is less than, so 0 origin is included in this solution set, included. What about next? So 0 plus 0 is less than or equals to 60. Yes, it is also true. So for this also we have the origin included in the solution set. Now let's draw the coordinates. So we have the x-axis and we have the y-axis for this, and let's plot these figures now. So 100 and 200, 100 on this x-axis and 200 on this x-axis, on the y-axis. So let's join these 2 points. So 100 and 200. Let's name this as 1500x and 750. 1500x plus 750y, it is equals to 150000, and the second line is 6060, which will be like this. So here somewhere I will get 60, okay, and here somewhere I will get it's 100, so here I will get some 60. Okay, let's join these 2 points now. Okay, 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 good. Okay, now both of these are what? Both of them are including the origin. So what will be the solution set for this is the common solution. Both are, of course, x and y are positive, so the common for solution set will be like this. Okay, so of course I am just drawing the rough sketches here, so these sketches may vary. So 100 and 200, and we have 60 60. Okay, so you may be wondering, sir, how you have written. No worries, yaar. See, for this line, this is what the solution set is, and for the second line, this is what the solution set is. दोनों का common region कौन सा है? ये common region है दोनों का, provided that x and y both are positive. So this is what your common feasible solution. Is it okay, everyone? I hope you have understood this concept. Okay, great. So with this, we have completed our exercise 7.2. We have seen each and every question in detail. Okay,